My name is Todd Gailey. I'm here to talk about Paclets and the new Wolfram Language Paclet Repository. I'm going to show off the repository. I'll talk a little bit about Paclets in general, and then I will talk about how to use Paclets from the repository, and including some what I consider to be best practices for consuming Paclet code, and maybe some things that are not obvious. All right, so there's my outline, which I already explained. All right, so Wolfram Language Paclet Repository has this lovely URL, paclets.com, but that's the long form. It just redirects to that. So we are here at this conference announcing this Wolfram Language Paclet Repository. It already has a bunch of great content. We're ready to accept user submissions. We're hoping that people have lots of things they want to contribute. Now, the Paclet Repository is not brand new. It was released in the spring. It was open for people to download Paclets and submit Paclets, but we really didn't make much noise about it because we didn't really think we had the developer workflow ironed out for the whole process for submitting in a neat form. We think we got that now, so we're basically ready to announce to the world that this is ready for business. So I think we can say now that the Wolfram system has its own package manager, similar to those in other popular languages. Probably familiar with the pip tool and the PyPy repository in Python, things like NPM and the NPM registry for JavaScript, Cargo and crates.io for Rust. Basically, most modern languages have some sort of package management system and an associated repository. And if you've used those things in those languages, you know how great those are, how important it is to the growth of the language to have a single repository where people contribute all sorts of things, a tool that's built into the system that knows how to get things from that repository. That is very important for the growth of a language, and we're very happy that we actually have this now for the Wolfram system. Very important aspect of the Wolfram Language Paclet Repository is that submissions are not curated. No human is going to look at your Paclet and approve it or not. Now, we do have some requirements that Paclets have to meet that they could cause them to be rejected, but a person is not going to look at it and say, no, I don't like what you've done here. You can't submit this. And another aspect of this is that when you submit something to the repository, it's basically made immediately available to the world. Right, so let's just go take a look at the repository. So here's the home page. We've got this little featured Paclets section. People might want to know how to get on the featured Paclets. I think it's mostly bribery. So there's a little alphabetical listing here. Now you'll see that there's not a ton of things here because we really haven't been advertising this much. There's a bunch of good things, but we hope to have many, many, many times this amount of content before long. We have things organized into categories. There are some Paclets that are quite large. Here's this Clauss-Suttner automata package. So this is what a Paclet homepage looks like on the site. There's a line showing you how to install it, and then something that it looks familiar as like a guide page for the functionality of the Paclet. You can see that this Paclet has a very, very large, like a very, very, very large number of functions in it. There are others. Here's one. It only has 2 functions in it, right? Directory size, browser open. And they have, you'll have examples and things, and every one of these things goes to a function page. This is the git link Paclet. This is contributed by Wolfram. Now you'll notice that this is the name of the Paclet. It's Wolfram/gitlink. Paclets on the repository have stylized names where the first component is the publisher ID. Require that Paclets have names in this format. It's publisher ID / and then some sort of short name for the Paclet. And so this one, Wolfram/ things that Wolfram/ are contributed by Wolfram. So there's some docs on how to use it. There's a bunch of function links to docs for individual functions. examples on this page. Then down at the bottom, there's some disclosures. It says local file. That means that this Packlet will read and write local files, right? And external services, it means it interacts with some external services. You might want to know if a Packlet you're downloading performs certain operations that maybe you're not comfortable with or something. You just want to know what it's doing, just like when you install maybe an app on your iPhone, it tells you about some of the permissions it requires. There's a compatibility section that you can read, version history, maybe you have a license that you want to put in here, et cetera, et cetera. Maybe a see also section. So we'll look at this Packlet again. Later on, there's a search field. So if you want to know about Packlets that maybe mention probability in their text somewhere, they're searching. There's a document getting started using the Wolfram Language Paclet Repository. I'm not going to go through this document much because it's basically the same thing I'm saying right now. I can plagiarize it because I wrote it. And then here's another very useful document, creating Packlets for the Wolfram Language Paclet Repository. And I'm guessing that when Bob's talk following me, will cover a lot of these topics as well. I do want to mention, I forgot to mention that we have quite a few Packlet-related talks at the conference. There's a long block starting with my talk. Then Connor Gray is talking tomorrow about some more advanced aspects of Packlets and Packlet development. And then most importantly, at 10:30 tomorrow, there's a workshop for Packlet development. We encourage anyone to come, people who are, maybe they've already started working on a Packlet and they're confused about something. Maybe they want some help with some aspect like authoring their documentation. Maybe you haven't started at all. You're just kind of curious how you might get started. We're hoping people will come and bring code that they've got, that they think, hey, I've got this code, I've had it for a while, and maybe I can package it up as a Packlet. Just bring it in. We'll have a whole team of experts to help you with all aspects of Packlet development and submission. All right, so there's just a brief little tour of the Packlet repository. So let's talk a little bit about Packlets in general, real quick. So they're just units of Wolfram functionality, and they're packaged in a way that allows them to be installed, discovered, updated, and importantly, integrated into the Wolfram environment. Right? And a lot of Packlets contain Wolfram language packages, probably most of them. But a Packlet can be a lot of different things. It can be as small as like a single documentation notebook. Could be a giant thing with many packages and its own documentation and front-end palettes, libraries, all sorts of things. Almost any resource that can be put into a Packlet. Packlets are heavily used within Wolfram research. In fact, there's around 370 Packlets in the Mathematica 13.2 layout. So the message here is that if you're creating any kind of content for Wolfram products that doesn't fit into one of our other repositories, like a single function for the function repository or a neural net for the neural net repository, if it doesn't fit in one of the existing repositories, then you should absolutely create it in the form of a Packlet and submit it to the WLPR. All right, so some general information more about Packlets. Packlets are versioned. The Packlet Manager basically cares very much about the version. The Packlet Manager is the component of the Wolfram engine that manages Packlets and weaves them into the system. And it cares very much about versions. It always wants to use the highest version number of any Packlet. But since Packlets are versioned, we can have side-by-side installation of multiple versions of a Packlet. Packlets have requirements. They can declare that they only work on a certain system ID. They only work with a certain version of the Wolfram engine or a certain range of versions of the Wolfram engine, or certain product names like Mathematica, or a Packlet can say, I only work with Alpha Notebook Edition, that sort of thing. Packlets that don't match the current system are invisible in that session. They will not be seen or used. And most importantly, really, Packlets have extensions. Extensions are the way the Packlet tells the package manager the things that the types of components that it has, the ways it extends the system. So a package can say, I have some documentation. I have a package file that should be found by needs, et cetera, et cetera. All right, so the fundamental principle of the package manager is that whenever the system goes to look up a Packlet by name or some resource that a Packlet might provide, the package manager finds all the Packlets that could provide the resource. It culls out any ones that are either disabled by the user or don't match the current system. Then it takes the one from the Packlet with the highest version number. So that's a much smarter lookup than your standard kind of dollar path-based lookup, which is just a linear order of lookup. And you should know that when the kernel looks up a file or almost any other kind of resource, the package manager gets the first crack at finding this. So something like dollar path is not even consulted, is only consulted if the package manager cannot find a file. All right, so it is the presence of a packet info file that makes something a packlet, right? You take a file sitting there on your disk, you put a packet info file next to it, you got a packlet. A packet info file is just a simple file of metadata in Wolfram language format that describes the packet, its requirements, and the ways that it extends the Wolfram environment. Packet info file is not code. You can't put arbitrary program into a packet info file. You can't even put 2 + 2 into a packet info file. It's like a metadata file. Even though it's in Wolfram language format, you shouldn't put sort of evaluatable code inside of a packet info file. All right, so here I'll just glance at a non-trivial but not particularly complicated packet info file. We've got this head packet object, and then in association with some rules, the name and version are required. You can't have a packlet that doesn't have a name and a version. You could have some short description. And then the extensions part is really the key. This is where you describe the things that your packlet has. So this packlet says, I have some extensions that the kernel should know about. And the root is a directory, the name of the directory in which these files will reside, a subdirectory of the packlet. And this thing says, okay, context is file utilities. So when someone types needs file utilities, packlet manager says, oh, I know the packlet that has that. It's this one, and it knows how to find the file. And documentation extension. And as you can see, oftentimes these extensions are very short because your package manager has conventions about where things would be. So if you just say documentation extension as like a one-line thing, then if you have your documentation in the standard location, which is a documentation subdirectory, then the package manager will be able to weave that into the documentation of the system. Same thing with front end. And I'm not going to talk about some of these, what these extensions actually do, but this is what a packet info file looks like. All right, so the packet system is documented. There's a guide page for Packlets. Here, I'll zoom this. There's function pages for all these are all Packlet manager functions that operate on Packlets in the system. There's also some, links to the Packlet tools documentation, which is another Packlet that has a set of tools for building Packlets that are really of interest to Packlet developers. There's also a couple tutorial type documents about Packlets. This long Packlets overview thing is kind of where you go for detailed information about Packlets and the structure of Packlets. Then there's documentation on the Packlet repository site. I showed you these 2 pages a minute ago. They're more oriented towards the Packlet repository itself. Then there's some information docs for Packlet tools and the documentation tools palette. So this stuff is all documented. The Packlet manager wasn't documented for years. I think people got into the assumption that there wasn't any documentation about the Packlet manager, but there actually is now. So using Packlets from the Wolfram Language Paclet Repository. So installing and loading. Okay, this page intentionally left blank. So I'll go to the Packlet repository, I'm going to use GitLink as a sample Packlet. So GitLink has this lovely little gray box. Packets will have these things with this little link. It's click to copy for how to install it. So I've done that. I'll go here. Paste it in. All right, Packlet install GitLink. Now, that executed pretty quickly, but it did have to download. I don't have Wolfram GitLink installed, so it had to download it. And I get this Packlet object back. I can open this up and I'll see that this location is down somewhere in my library Mathematica Paclets repository directory. All right, so if I want to use this thing, I'll go back to the browser. I'll do a click to copy on that. Paste that in. Now you notice that Packlets that have a context, the context is trivially derived from the name of the Packlet. So the Packlet is Wolfram/GitLink, and the context should be Wolfram backtick link backtick. And you can count on that. I just did a click to copy to get this thing. All right, so I've now loaded. So I mean, this is it, Packlet install, right? That's pretty easy. And then if it has code, you do have to call needs on the thing. So let's just, prove this works. Say I'm gonna set a directory, and then I'll call a function from the Packlet git clone, right? That is cloning. This is the LSP server repo. Maybe you've heard about LSP server. I just chose this. This code is actually, code for LSP server is actually all on GitHub. Tiny little summary box that came out, just doesn't zoom properly in the presentation notebook. But I think if I type information of that, I think I get a nice thing. I guess I don't. See, never try anything in a talk that you haven't done once before. There's something that information operates on. All right. All right, anyway, finding Packlet. So Packlet find remote is the function that looks for known Packlets with a certain name or other properties on any known Packlet servers. And now Packlet find remote works and Packlet install works because the Packlet manager, because Mathematica knows about the Wolfram Language Paclet repository by default. So I can say, okay, Packlet find remote is like, I know there's a Packlet that has Mockingbird in its name, so I can do something like this with a string pattern, and I find this Packlet object. If I open this up and see the location of this Packlet is on the Wolfram Paclet repository site. All right, so Packlet find remote lets you sort of in a programmatic way find Packlets. Then you can also, because the Packlet system is integrated with the resource system, you can also use resource search to find Packlets. So this is going to find me all Packlets that are available out in the world that the resource system knows about that start with Wolfram / that have a publisher ID of Wolfram. And this returns it in a sort of a readable data set form. All right, so that's searching. And then of course, if I want to uninstall a Packlet, it's just Packlet uninstall. And now it's gone. All right. So we've all seen, so now we're going to talk about what I think are sort of good practices for using Packlets. The shadowing problem, we've all seen the shadowing messages that come up when you get two symbols that are from different contexts that are both visible, the same name, that are visible at the same time. We actually expect this to become a much bigger problem as the Packlet repository grows. I don't know, in that Automata Packlet, for example, I'm sure you didn't notice in that huge long list, but there's a symbol called pairs, there's a symbol called words. I mean, there's going to be some conflicts with Packlet, symbols in Packlets, right? People are it's just a zoo out there. It's a free-for-all in terms of how you want to name your functions in your Packlets. So there are various techniques for handling this. One is context aliasing, which was a new feature in Mathematica 13, which I think people should, I talk about quite a bit. I think people should understand it. If I'm defining some function with a long context name, and then I can, in this line, will assign a context alias of CC backtick, basically is the short form for that long context. So then I can call CC backtick square of 5. Now, the real value of context aliasing comes along with this new syntax for needs. So if I want to load, needs, if I want to load the developer context, if I do it in this way, it acts just like needs, but it does two important things. One, it establishes this context alias of dev for the longer developer, but really importantly, it does not put developer on the context path. So now I can just call some function like this, and I don't have to. And if I that's wrong, I guess I'm not going to type it out. Developer is not on the context path. So this is a way of loading a package, making its symbols available with a alias, short alias to this context, but not having all the symbols to the global namespace, the sort of soup of visible symbols. So this is what it looks like for a Packlet from the Packlet repository. I've got this Packlet that is, Wolfram code equivalence utilities, install it. And if I call needs in this form, I can now use this short alias for when I'm calling functions from this Packlet. And I have absolutely no idea why I got those messages, but it does say true. So there you go. And you can see if I can check that Wolfram code equivalence utilities is not on the context path. So the point is that okay, if you just want to let every Packlet that you call needs on dump all of its symbols into your global namespace, go ahead, it's fine. But as we get more and more Packlets and people start to depend more and more on coding Packlets, I think that you should get used to using this type of syntax where you don't load things where all the symbols become visible, but rather load them in such a way that you can use them with a very short context alias. No, that's a question people say, well, but the thing is that the context alias that I want, that's like my decision, right? If you said, oh, CE is going to be my context alias for my package, then you have the same problem. Some other Packlet author might decide that CE is the right context alias for their package. So it really has to be on the individual. So I do think, I think that people should get used to writing this type of need statement instead of just needs. All right, and then I'm going to talk about, I know I'm running out of time here, but we'll try to do this at 30-minute intervals, I think, for this block of talks. So Packlet Symbol is a new function in 13 that lets you invoke functions from Packlets in a very convenient way. So here what I'm doing is I'm calling this function quantum basis from the symbol from the Packlet Wolfram Quantum Framework. And I don't have this Packlet installed. But if I just run this one line, it will go and install the Packlet and run the function. So this single Packlet symbol call lets me call this function without doing anything at all other than just executing that one line. So Packlet symbol, it finds the Packlet, it finds the name Packlet resource and installs it in a special way. It loads the Packlet's main context, but does not add the context to context path. And then it evaluates to the actual name of the symbol. So Packlet Symbol does a couple things for you. When it finds and installs the Packlet if necessary. If the Packlet's already installed, it doesn't have to do that. And it also loads the context, the Packlet's main context, but does not put it on context path. And how it installs the Packlet, it installs in such a way that it's made visible in the current session, but it was not visible in sub-sessions. Now, Packlet does not need to be downloaded again. If you invoke Packlet Symbol in a future session, then the Packlet was instantly loaded and used again. It's not expensive to do that. But it's kind of like we can sort of imagine this as like a try before you buy type of thing. I can just go to I can call Packlet Symbol to invoke some function from the Packlet and have it run in my system. And if I don't care about that Packlet, I can just ignore it and the Packlet will not be present the next time I start the kernel. And one more, all right, so actually I should mention that on the Packlet repository, you'll notice in some of these examples, there's this little summary blob here. This is Packlet Symbol, right? So I have clicked to copy, right? So if I click to copy this, you could think of Packlet Symbol as being a really handy thing for doing click to copy. I get this blob, which if I hover over, you can see is really just evaluates the Packlet symbol. It's just a representation of the Packlet symbol function. So that's what it lets us do. Click copy from the Packlet repository. You see an example you like, click to copy, paste it into your session. It's just called the Packlet symbol. And so that will download the Packlet if necessary and use it, but not clutter your future life with a full install of that Packlet. Okay, and then finally, just some things that people might not appreciate. Let's say I'm going to use a code from the Packlet in my own package, I'm going to give this to somebody else. So I have to put Packlet install somewhere in my code because I want to make sure that people who are using my code's not going to work if this other Packlet is not present on their system. But if I just call Packlet install on Wolfram GitLink, what Packlet install does is it will install it if it's not present, but if it is present, it will also install an update if an update is available. And it's really probably bad form to have a side effect like that on your user systems, right? I don't want to give someone code that's going to cause them to get a newer version of a Packlet that they've already got. And so if you use allow version update false in Packlet install, that will get the Packlet if the user doesn't have it, but if they have any version of it, it will just use that version. So I think that people should get used to putting code like this in their packages. If you need to call Packlet install, use allow version update so you don't cause a side effect on user systems or your own user systems. And finally, another way to do this, I think a very slick way to do the same thing, is to use Packlet Symbol. And I think so. If I want to use a handful of functions from Wolfram GitLink in my own package, I can put Packlet Symbol calls in my package, in the private section of my package. So I define my own functions, git clone and git pull, that just map to those symbols. And that's all I need to write. When that code runs, when this package loads on a user system, it will install the Packlet if necessary, but not put the symbols in the user's context path. And it will not cause an update. Packlet Symbol will not do the update thing. So I think we kind of have a nice structure here where you have the section of your code where you're essentially importing the functions that you want to use from Packlets, and you're doing it in a very simple way and in such a way that it does not cause the Packlet to be updated on the user system. Okay, Bob is going to be up next to talk about submitting Packlets to the Packlet repository, getting started with that. I'll say thank you very much. And I don't think I have any time for questions, but thank you. Well, maybe. Go ahead, Julio, while he's getting set up. Yes. The question is, can you, not in needs, but in Packlet install? If I say Packlet install, Wolfram GitLink arrow 1.3, it will install that version. Okay. So yes, you can specifically name a version in Packlet install.
Second quick question that you might have already answered is Packlet Symbol. My question from before would have been, how can I do a need to an alias, but only for a single scene? Is Packlet Symbol the answer to that, or is for a slightly different?
No, Packlet Symbol, it's going to load the entire package. There's no, if that's what you're asking.
No, it's still loading the entire, because if you do the alias, code equivalence goes to CC, that every symbol is available under CC. If I want only one function of code equivalence under CC.
That's not available, but it's an interesting idea.
But it's close to this.
It's close to this, yeah.